In example number 6, we want to identify vertical asymptotes and removable discontinuities for a graph. So let's go over the definition of a removable discontinuity. It occurs in the graph of a rational function at x equals a if a is a 0 for a factor in a denominator that is common with a factor in the numerator. We factor the numerator and denominator and check for common factors. If we find any, we set the common factor equal to 0 and solve. This is the location of the removable discontinuity. This is true if the multiplicity of this factor is greater than or equal to that in the denominator. If the multiplicity of this factor is greater in the denominator, then there is still an asymptote at that value. So for example 6, we want to be able to find the vertical asymptotes and removable discontinuities of the graph of k of x, which is equal to x minus 2 over x squared minus 4. Now the first thing we need to do, regardless of any of our rational functions, is to factor the numerator and denominator. So the numerator is already in factored form, which is x minus 2, and the denominator is x minus 2 times x plus 2. So if you notice, you have x minus 2 and x minus 2 are factors. So we would be left with 1 over x plus 2. So notice that there is a common factor in the numerator and denominator. So that means we have x minus 2, which is equal to 0, and therefore x would equal 2, or the 0 for this factor is x is equal to 2. And this is where the location of the removable discontinuity is located. So therefore, we know that x equals 2 is part of the ordered pair. Now, if you notice, we also have in a denominator, we have x plus 2. And that x plus 2 is equal to 0. And that remains, so x equals negative 2 becomes our vertical asymptote. So we can see there's our vertical asymptote. So now, if we want to be able to find out where that hole is located, then the remaining function is 1 over x plus 2. So if we have the function f of x, which is equal to 1 over x plus 2, we want to find out what is the output when x is 2, since 2 is where the location of the removable discontinuity is. So we have 1 over 2 plus 2, which is equal to 1/4. So therefore, at the ordered pair, 2, 1/4 is where the hole is located. So the graph of this function will have a vertical asymptote at x equals negative 2, but at x equals positive 2, the graph will have a hole.